Good afternoon and welcome to today's celebration of electricity innovation. My name is David McKendry, Senior Fellow at the Canadian Electricity Association. Every year, CEA celebrates innovation from coast to coast to coast and inducts projects into CEA's Electricity Center of Excellence. While 2020 has been an unusual year for all, there has been no less innovation from our member companies. This year, we are pleased to announce 19 new innovative projects ranging from customer-facing call center improvements to renewable generation projects. With these 19 projects, we now have a total of 75 projects in our Center of Excellence. I hope you enjoy learning more about today's projects, and thank you to all our member companies for your impressive, innovative projects.
Faucet River is in central Alberta, 2.5 hours north of Edmonton, and ATCO has a telecom site north of the river. So ATCO has a large distribution and transmission network in Alberta, and it has its own telecom network to support that electrical grid, basically. The telecom site is a backbone site to the Peace River and Fort McMurray regions. And basically, it's a mobile repeater site. The site is so remote that there is no power line close to the site. As a result, to supply the telecom equipment, 2 diesel gensets were running 24/7 to supply the telecom equipment there. ATCO decided to convert the site to a hybrid system, which includes solar and battery, and propane gensets as a backup. I was the design engineer for solar and battery system there. So brownfield projects are always a challenge. Integrating new technologies with the old assets is always a challenge. And in this case, our SCADA and PNC team worked really hard to configure the microgrid controller properly and make sure that the controller properly communicates to the new devices as well as the existing ones. These types of projects like Faucet River, they will be the new normal. They're here to stay. Actually, ATCO is looking at 100% solar or a hybrid system such as Faucet for all the new telecom sites or the sites that the generators are at the end of the life, and we need to make a decision about replacement. Now, can you imagine how many of these sites we have across Canada? Like big communication companies such as Rogers and TELUS, they have many of these sites. RCMP, forestry, oil and gas sector, utility companies, they all have these remote industrial sites that are running on diesel 24/7. So if you're looking at a net zero by 2050, the transformation must start from today.
The Genesee generating station provides over 1,300 megawatts of reliable baseload generation for Albertans, and it's Capital Power's largest generating station. It's a foundation for Capital Power. It's often referred to as our flagship. Recognizing the importance of carbon reduction, Capital Power focuses on emission reductions, reliability, and sustainability. So when Genesee Unit 3 was built, we used state-of-the-art technology, and Capital Power agreed to impose at that time a voluntary reduction of the coal unit's emissions to the equivalence of a natural gas combined cycle facility. So this efficiency project put a target to Genesee's emission reductions. We're going to improve the greenhouse gas emission intensity and the performance and the efficiency of the unit by 12% by 2021. The result is lowering the plant's emissions by approximately 1 million tons and carbon compliance cost savings for Capital Power under Alberta's carbon pricing framework. The project preserves and it extends the value and the life of Genesee to keep it as a competitive source of power generation and a major contributor to the province's power needs. So sustainable energy, I think it's important to Canada's economy. Capital Power is committed to responsible generation. Reducing emissions through the Genesee efficiency project was the first step for Capital Power. The path forward for us would be converting our generation through innovation and technology, deploying a multifaceted approach to decarbonization. Genesee has been integral for the last 30 years to Alberta's power needs. It'll continue to be for years to come. Projects like our Genesee Carbon Conversion Center, it's an opportunity for us to look beyond just energy. We get a chance here to partner with new industries to grow Canada's economy and reduce emissions together. Capital Power has partnered with C2CNT to develop this carbon conversion center using this new technology. It's building the world's largest carbon nanotube facility, which has the benefit of impacting carbon emissions by using carbon nanotubes, a valuable product in other applications such as additives to industrial processes like cement. It's an opportunity to expand and partner with industries outside of just energy. The project reduces emissions through carbon capture, and then that end product has the ability to transform other industries, reducing their carbon footprints exponentially as well. It's a partnership. The Genesee Generating Station has been around for 30 years, so a lot can happen in yet another 30 years, which the site will be around for even longer, we hope, and it'll include things that we can't even imagine today. I think COVID is a good example of where things can, how things can change and how we've had to change our thinking. Genesee is a hub. It's a hub of innovation, both in terms of power generation, finding new opportunities for creating a low carbon world in other industries. Capital Power is a team of future focused experts and creative minds. And aside from being, net zero at the facility by 2050, I think Genesee will be producing new and exciting products that we can't even yet imagine, and which will contribute to a strong and healthy future for all of us.
This project is basically the high penetration of a renewable generation in distribution system has introduced more uncertainties and a lot of technical challenges from the operations side in the distribution system. And due to intermittent nature of this renewable generation, it is essential to develop some sort of a technique so that we can manage and balance the voltage load and voltage profile. The optimum power distribution is also help distribution losses, and it will provide adequate power capacity and availability to the customers. The project is very important for Lexicon Energy because it is using existing asset, the inverters installed at our customers, and utilizing their unused capacity to provide system benefits, which includes power quality, energy savings, and eventually it will help reduction in energy bills to our customers.
I think the biggest challenge for the power quality challenge, as I see, is the integration of renewables. The solar is growing at a phenomenal rate across the world. And one of the biggest challenges in integrating solar is the rise in voltages. The moment, because of the real power that they generate, the voltage starts to rise. So that's the most significant challenge, the power quality challenge that comes because of integration. And there is a limit on how many solars you can integrate on a line, because the voltage will start violating the utility limits. So the challenge is that how do we control the voltages by the solar systems themselves? So solar systems, they create a problem. But now with smart inverters, the solar inverters can solve their own problem that they created, plus solve many other challenges which are created by other things in the system. So this is where our project starts. So what we are doing here in this project is we have developed a patented technology of using solar farm in the night. The important thing to remember here is that the inverter and the entire asset is available, which is sleeping. So we developed a technology of transforming the internal of the inverter into a dynamic reactive power compensator by which we can control the voltages in the night as well as during the daytime. And we have applied not just to the solar inverters, but also to the battery energy storage systems, which are actually in existence in Falguni's Lexicon network. And what we are trying to do is, just to summarize, reducing line losses means that you must reduce the differences in voltages across 2 points, because the lesser the difference, you have smaller current and consequently smaller I square R. And the second thing is for conservation voltage reduction, we have to reduce the voltage a tiny bit by 1 to 2%, and then we can have very large amount of saving. And all this voltage control can be affected by the reactive power, which is available from the solar farms in the night, as well as early morning, late afternoon, and also from battery energy storage systems when they are not charging or discharging. So as Falguni mentioned, that we are using existing resources, unutilized resources, for bringing in very nice benefits, which are for the utility customers, because if we reduce the line losses, right now the losses are being passed on to customers. So if we are successful, and we have done some studies to show that effectively, it impacts the customers' bills hopefully will go down. And also because of less heating in the lines, their lifespan gets increased.
Since this intermittent renewables, we don't have any control. So we don't know when wind is going to blow or when sun is going to shine. The best strategy to cope with this is energy storage, either underground or battery storage. And since we all are striving towards this reduction in carbon footprint, and energy users are also more aware and they wanted to be participant in saving the environment, I can see that more and more customers wanted to have their own energy usage and energy generation.
Intermittent sources are here to stay. In fact, according to an International Energy Association report, by 2050, about 38% of global electricity is going to come from solar itself. And almost about 30% will come from wind. So almost you can say about 70% is coming from these intermittent sources. So we have come to live with that. And the technologies have evolved so that the intermittency can be smoothened out. When you have intermittency at a large scale on different solar farms, for example, they tend to balance out because different shading effects happen at different times. Similarly with wind. And also there are power electronic controls that have been developed so that you can smoothen out the power from a solar plant. In fact, a 300 megawatt solar plant in California does the same thing. So they can smoothen out their power system, the output, just by the control of inverters. So that is part one. But to couple that with energy storage system, you have the best of the worlds. You know, you can store the energy, you can smoothen out, and you can use it when sun is not there or when the wind is not there. So I don't see intermittency used to be a problem. I mean, there was a big worry, but there are technologies available, both from inverters as well as energy storage, by which this is getting solved. And in fact, it's going to grow even further, as I mentioned.
Hydro Ottawa achieved this certification through actually many years of hard work. It first began with us conducting a gap analysis against our system to understand kind of how far off we were and what advances we were going to need to make in order to actually achieve certification. From there, we spent many years collaborating and working collectively as a team in order to close those gaps until we finally got ourselves to a place where we felt we were ready to actually challenge the certification and actually become officially ISO 55000 certified. So what it means to our organization is that we get to showcase to the rest of the industry the asset management system that we have in place and the great system that we have managed to collectively develop as a team, and that we also get to ensure that our customers get to reap the benefits as well of the asset management system that we have so long worked hard to put in place. I'd say ISO specifically, the standard matters because it gives everybody, so when people think of ISO in general, very much so I think most people's minds at this point in North America in general would go to the 9001, which is something you see from like the manufacturing side quite a bit, and you get it comes with essentially a guarantee of a certain level of quality. It's a recognized standard that around the world that people know that they're getting something consistent, and that there's a certain level of predictability as well on what you're going to get when you look at it from the manufacturing side. And so there's so people know they're getting a good quality and consistent product. So the reason that I feel like these types of certifications matter is because it actually gives our customers a sense of an understanding that we have a good control of our system, that we are adhering to something that's internationally recognized, and that we're therefore spending their money wisely and making their investments soundly.
In 2010, we built an in-house system to help manage the workflow of our service desk requests. And, over time, being an in-house system, it really needed to have a huge overhaul done to it by about 2017, 2018. And so as we looked at, what the system could do for us and in combination with some of the other projects that were going on within the organization, it became very clear that it was time that we moved on from that legacy system and looked for a system that was going to provide a much better and clearer customer experience. We've introduced an opportunity to communicate throughout the different stages of the life cycle of the jobs. So we're pushing notifications because traditionally we would wait for a customer to reach out to us to book an appointment or to arrange for payment and that sort of thing. And so now as the job progresses through its life cycle, there are key points, touch points where we're able to send out an email to a customer and say, hey, your job's ready to be booked. Give us a call when you're ready. Or, hey, this is great. We've received your payment. We're ready to move to this next step, which is a huge improvement for our customers. And also by eliminating the middle person, we used to have to dispatch all of the requests that came in. And now with this new technology, we're able to direct their request to the individuals that's going to get the work done for them. It's giving us the opportunity to provide a 360 view of our customers, right? So we know what's going on the billing side, but we also know what's going on the construction side. We know what's going on a planned outage side. Whatever that looks like, it's all going to be in one place, right? So it's going to be a much better experience for our customer. That roadmap is expanding and it's, we are expanding that digital experience. And that is to meet the needs of our customers. That's what they're looking for,
Oui, donc une des priorités d'Hydro-Québec, c'est d'assurer la fiabilité, la pérennité de ses actifs et notamment de son réseau de transport d'électricité pour offrir le meilleur service possible aux Québécois. Donc, pour y arriver, la connaissance de l'état des équipements du réseau est vraiment essentielle afin de bien planifier les actions de maintenance, les actions de remplacement, ou encore lorsqu'il s'agit de changer les conditions d'exploitation d'une ligne en augmentant le courant, par exemple. Donc, notre unité robotique, c'est notre credo, on y contribue depuis des années. On a développé de nombreux porteurs depuis plus de 20 ans maintenant, des porteurs robotiques que l'on installe sur les lignes avec soit des câbles, des poulies ou des perches, puis on y associe des sondes de mesure. Les mesures par contact, elles vont nous permettre de fournir de l'information qui est impossible à obtenir à distance ou encore sans réaliser des prélèvements destructifs. Donc, dans ce contexte, le développement d'un drone capable d'atterrir sur les conducteurs énergisés, pour pouvoir utiliser nos sondes, nous est apparu comme une continuité naturelle avec pour grand avantage d'éviter à nos monteurs de devoir réaliser des ascensions de pylônes. On élimine le danger à la source, on favorise un déploiement très rapide et on peut travailler sous tension. Donc, le choix qu'on a fait, ça a été de développer cette technologie-là parce que le défi principal, c'était l'immunité au champ électromagnétique et c'est au cœur de notre expertise. Pour des inspections par drone plus standard, à distance, le marché s'en occupe très bien, les industriels s'en occupent très bien. Voilà. Puis je dirais que je pense que nos porteurs robotiques qu'on installe sur nos lignes, qui roulent sur nos lignes, ont encore de bons jours devant eux parce que ils ont des caractéristiques complémentaires à notre line drone. comme une faible sensibilité au vent. Ils sont capables de transporter de lourdes charges, ou encore, c'est possible de les opérer sur plusieurs kilomètres, ce qui n'est pas encore permis avec les drones au Canada. Ça sent bien, mais ce n'est pas encore permis.
With the increasing concern and awareness surrounding wildfire mitigation in California, Liberty did identify the Sage Hen Tap as possibly having wildfire risk. This line is currently 4 miles long. It has 90 poles and it only serves a single customer, the UC Berkeley field station. Not only that, but it does extend through environmentally sensitive lands. So to harden the line and make the line safe for wildfire season would have cost Liberty over $3 million. And construction likely would have taken over 2 years with environmental permitting. So knowing that, Liberty went to seek alternatives to provide resiliency to that single customer and lower costs where we could. So the solution that Liberty came up with was a solar plus battery storage microgrid. It consists of 24 kilowatts of solar panels and 54 kilowatt hours of battery storage. And the great and unique thing about this project is that the customer will be served purely by the microgrid during wildfire season. We will be completely de-energizing the line.
We look at innovation from a customer-centric lens. We look at what our customers' top priorities are for their energy needs, and then we look for solutions around them. So our customers are typically looking for lower price, they're looking for green energy, or they're looking for resiliency, or some combination thereof. Sometimes it's 2, sometimes it's 3. For projects like Sage Hen, it was really a resiliency play. We're seeing increasing numbers of extreme weather events and then increasing outages because of that. So in this case, definitely microgrids provide a great solution for resiliency for our customers. And in this case, it was also a lower cost solution, which is great.
We in 2017 determined from a customer request that there was a need to put a charging infrastructure throughout the province of New Brunswick. So we started initially with charging at the Quebec-New Brunswick border, and then we continued it on the Trans-Canada Highway down to the province of Nova Scotia. But then we determined there was a further need around other areas of the province, so we continued that corridor throughout the northern and the eastern part. And this is all made possible through NRCan funding and the province of New Brunswick. So we were very excited. At that point, we now have chargers throughout the entire province. One of the most significant barriers to EV adoption, which has been addressed and will continue to be addressed by the eCharge network, is the availability of the charging infrastructure. Through this funding through NRCan and the province of New Brunswick, we were able to put chargers at 63-kilometer intervals along the major highways throughout the province. So this charger availability provided drivers with confidence that they can travel the entire province without the fear of running out of a charge. And, from recent customer research, it has shown us that drivers do not feel they have the range anxiety they had a few years ago, and they're now more comfortable with an EV purchase for their next vehicle.
Fantastic little project in the town, the coastal town of Shediac, New Brunswick, the lobster capital of the world, which includes 3 key components. One is a solar farm. The second is the desire to get 2 large buildings in the community, about 1 megawatt load and a 300 kilowatt load, to net zero over the course of the next 2 years. And then the third piece, a really complex piece, is a residential research project where we'll be deploying and installing DERs in about 500 homes in the community. Everything from solar panels to energy battery storage to smart water heaters and even smart heat pumps. There's so much we've learned already, and so many ways in which we recognize that we need to continue to evolve. I think that the learnings are that the desire significantly outweighs the capability. So what I mean by that is that the desire for communities to have these options, to take advantage of federal funding, to deploy their own large-scale solar farms or battery storage to offset their own costs, to create more resiliency in their community, to position themselves as green or smart energy communities, worthy of investing in and worthy of moving to. I mean, this kind of movement and evolution endures in renewables is very much tied to economic development, obviously, and positioning of communities. I know one thing here in Atlantic Canada, in fact, in Shediac, what we're seeing in this kind of COVID period is a significant group of people from outside the Atlantic bubble looking to move to New Brunswick. And, Shediac is using this project and its desire to be a smart energy community of the future and a very renewable community as a lure to draw professionals from, say, Ontario to move here, buy property and live here and work from here. So we're all part of something, an evolution in the industry, obviously, but that evolution is tied, like every evolution in an industry, it's tied to societal change too. The expectations on utilities in terms of stakeholder relationships and customer management and the ability to explain, say, infrastructure investments and how all this ties together. The expectation on us is intense. If it wasn't already intense, our ability to communicate and speak to these things is only expanded exponentially.
Our sort of tagline and goal is really to make EV charging, fast charging, easy, reliable, and seamless. We really want to give drivers in Ontario a place to charge from east to west and north to south, and give them a place to charge wherever they are in the province.
So today we've got 18 sites live all across the province, all fast charging sites. As we grow and develop, by the end of next year, we're going to have 70 sites, or over 70 sites live with 160 chargers. So we're going to continue to grow the actual size of the network. And then, of course, EVs is an emerging technology. So our goal is going to be to continue to adapt as the technology itself continues to change, and be ready there to provide a high quality service to our customers.
Bringing programs like this, the Home Heat Saver program, is really important. Many of our customers in St. John struggle with heat loss. Nearly 40% of St. John homes were built before 1960, so we have a very old mix of homes. And the primary source of electricity of heat is electricity. So our goal is to provide customers with more information and develop tools that will help them better understand their energy uses. It's a very visual application. Basically, by logging onto their account online, they'll be able to see a personalized private heat loss map, and it basically is a thermal image of their rooftop. So based on the amount of heat that's escaping the home, customers will receive a heat score that only they'll see, and they'll be able to compare their score to the city and to their community. We actually had MyHeat, which is a company based out of Calgary, use their really cool technology. They had a thermal plane that went over the city and basically did a thermal imaging of all the homes in the St. John area. I think as a utility, our responsibility is really to make sure that everyone can afford some of these upgrades, to make sure that they're being the most energy efficient as possible. So that's the plan, and we're very excited. All this data will be coming in, and we'll be able to sort through it and really become closer to the customer and understand what types of offers that we as a utility can provide to our customer base.
This project is basically the Electricon's vision towards the futuristic utility. At Alexicon, we have done mimicking residential microgrid project at our headquarter office. And then we wanted to do something which can benefit beyond the residential customers, which can help our community or commercial or in future industrial customers too. So when there is a ministry, Smart Grid Fund came up, funding came up, Harry from Opus One as well as Alexicon started talking about that, how can we utilize this fund and then demonstrate something which can be benefit to the utility as well as customers too. And that's why all this project has came up. And then eventually we contacted our local builder, Marshall Homes, and then they were about to build the new community, and they have also innovation vision. So three of us together with the help of ministry funding, and at the end we combined the IESO Innovation Fund for this project for smart grid extension and beyond vision. And that's how this project whole came up. The one factor I wanted to say uniqueness about this project is this is a first in kind of a planned community microgrid, because a lot of people has done microgrid project, but this community has one resident which has another microgrid to itself. So this is a microgrid within microgrid and nested microgrid. So this is a first in kind in Canada planned nested community microgrid project with renewable energy as well as battery storage. The another uniqueness is because this battery storage unit is a three-phase unit, we need to bring a three-phase power into the community. Usually we have seen that all the subdivisions or community townhomes are fed by single-phase power, but this is a three-phase because the uniqueness nature of the power pack we are using at the community. And that's what the uniqueness came from.
The inspiration for this project was really all about being able to respond to our customers and understand what they're looking for when it comes to connecting to the grid. And so those customers, they're changing, and their expectations of working with the utility, they're changing as well. No longer are they going to be patient in working with us in, a paper-to-paper environment. This is really about moving into more of a digital environment. And so we wanted to make it easier for our customers to connect both the traditional load to the grid, but also some of those non-traditional, newer distributed energy resources that we're seeing as well.
From our perspective here in Calgary, Alberta, one thing definitely to consider is when we're talking about DER, when we're talking about self-generation, a lot of it really comes down to customer economics. And does it make sense to our customers to want to put this equipment in and install it on their side? We're always going to have, and we've definitely seen customers with keen interest that want to get involved and want to really start to move forward with these kinds of technologies independent of the price. But if we look back over the last few years, where we really started to see an upswing about 3 years ago, 2.5 years ago, was as a incentive was released in the province, which lowered the price for renewable DER and self-generation. And really what that spawned for us was a significant increase in rooftop solar DER specifically that we were seeing on the residential side significantly. And then also on the commercial side, we started to see larger commercial installations as well of predominantly solar PV renewable generation.
The service to our customers is our primary responsibility and something that we're very proud of in terms of what we deliver from a reliability perspective. So anything that we can do to enhance the customer experience, and that includes reliability, is something that we focus on. So we're always looking at ways in which we can do what we do better, cheaper, and in a way that impacts our customers less and less.
So in terms of identifying a cable fault, reactively, it's still the same process where trouble response crews will continually restore the outage as they isolate for the root cause. But the big difference that we're making here with this tool is that we're changing the proactive maintenance and we're improving upon identifying assets that have the higher probability to fail. Essentially, we're taking data and math and supporting more data-driven decision-making with asset management.
So ultimately, what our customers want is a reduction in the duration and frequency of outage events. What this tool has been able to help us with is to identify the high risk cable sections that will fail and proactively address them. Hence, reducing the number of unplanned events that our customers experience, and also being proactive in our customer engagement aspect, reaching out to the customers if there's a need to proactively replace a cable, getting them involved in the process, and helping our customer satisfaction, making sure our customers are happy with the service they're getting. With at NMAX is what we strive for.
Well, Shepard Energy Centre is Western Canada's largest combined cycle plant. It's a Mitsubishi 501G 2-on-1 combined cycle plant. It's got an output of about 860 megawatts. And NMAX, you can imagine a plant that size uses a lot of water. When the plant was designed, one of the key aspects of the design of the plant was the use of reclaimed water from the Bonnybrook wastewater treatment plant here in Calgary. So that's one of the plants in Calgary that treats domestic water that's sewered. And the effluent from the plant would typically go to the Bow River. And when Shepard was designed, we built a pipeline from the wastewater treatment facility to our plant, and we used the wastewater from the effluent, I guess, from Bonnybrook for all of our process requirements. So that's for our cooling water, and then we create demineralized water from this effluent as well. The sampling techniques that Shulamit talked about and the water chemistry approaches that we're perfecting at Shepard can benefit not only combined cycle plants, but really any large user of water in an industrial process anywhere. So, I think there's a lot of application for this. We see that water is a precious resource, and anything we can do to make better use of water, I think we'd like to see that applied everywhere it can be.
Utilities move power at very high voltages for efficiency and then use our substations to reduce the voltage for our customers. Substations really are a key part of the system and help utilities control the grid. Standards play an important role in the utility. As you can imagine, everything utilities do or construct is getting more complex as technology evolves. Standards set minimum or common requirements across utilities and industry. Standards help improve safety, they reduce cost, improve reliability, and potentially enhance performance for most utilities. Standards allow utilities to focus their training of staff, and it also allows us to align our maintenance. For us, 61850 greatly reduces wiring in our substation, which translates to reduced construction time and construction costs. For us, it's about speed, and it has allowed us advanced protection on our system, which is better for customer reliability, reduced chance of equipment damage, which really is about cost savings. It allows us to reconfigure our protection systems in much shorter time. It increases reliability to the customer and reduces troubleshooting. Because of all this, we see a reduction in commissioning time, and it's positioned SaskPower better for the future. Bottom line really is this translates to better customer services, and I know you're thinking how. What this does is it allows for complex remedial action schemes which reduce costly system reinforcements, which really impacts our customers. The automation results in reduced customer outages, both in duration and frequency, and SaskPower can tell large customers the reason for the outage and the time to restore before they even call, which makes us well prepared to serve our customers. So for SaskPower, we're looking at advanced distribution management system right now, full AMI meter installation for outage reporting, automating substations to have a complete visibility of our grid. We're looking at smart switches and smart reclosures, and eventually automatic switching.
Thank you for joining us today for the induction of today's 19 innovative projects into the 2020 Center of Excellence. We hope you'll join us tomorrow on this platform for a series of engaging discussions and keynote speakers. We look forward to presentations by Gerald Butts, Vice Chairman and Senior Advisor of the Eurasia Group, and Avery Shenfield, Chief Economist at CIBC Markets. Our annual Powering Partnerships event will kick off at 11:30 a.m. Eastern Time. Thank you, and we'll see you tomorrow.